Hey scholars, I hope you're doing great today. For this lesson, we're going to need to use our calculators because we are going to use them to help us find missing side lengths in right triangles. So we're going to use the trig ratios that we've been learning about, and we're going to apply them to help us solve some problems here. So make sure you have that calculator, take good notes, and pay close attention. Let's get going. Alright scholars, like I said, you will need your calculator for this, so make sure you have it. What we're going to do is find missing lengths in right triangles. And we're going to use trig ratios to do that. So in order to do this, you might want to write this down here. To find missing lengths of right triangles, we must take the information we are given. So you're going to be given like the measure of an angle and also the length of one side. So then after you identify the information you're given, you're going to use the appropriate trigonometric function to find the missing side. Okay, so we are going to work through problems like that. And after we work through a couple problems, you might want to look at these examples here on your slides to just kind of drill that in a little bit further. You'll have a couple examples right here. So let's go ahead and move forward and work these out. So we're going to find each length and round our answers to the nearest hundred. Okay? So number one, we are trying to find the length of MP. So side MP here, so this leg of that right triangle, we're trying to find that MP. All right, so what we need to do is first identify what we are given. What information are we given? Well, we know that angle N is 20 degrees, okay? And then we know that the hypotenuse, NP, right here, is 8.7 centimeters. All right. So we're going to use that information to help us find MP. And this is why these trig ratios are so helpful. We're only given one side length. Usually we have to have two side lengths in a right triangle to find x. Or remember when we dealt with special right triangles, we were given one side length and we knew the angles, right? Like a 30, 60, 90, 45, whatever. We only needed one side length because we knew the angles, and we could use the tricks that we had learned to find the other side lengths. Well, now we don't need just it to be a 30, 60, 90 or a 45, 45, 90. It can be any right triangle, and we're going to be able to find the length of any of the sides. So, again, like we said, we're trying to find MP. We know that angle N is 20 degrees, and NP is 8.7 centimeters. So now that we have our information that's given, we're going to use our trig ratios. So we're given the hypotenuse, and in relation to this angle that we're given, angle N, what is this side in relation to angle N? Is it the opposite or is it the adjacent side? Well, NM is the adjacent side, right? Across from angle N is the opposite side. So we're not going to use the adjacent side. We know nothing about it. We know the hypotenuse, and we're trying to find the opposite. So opposite and hypotenuse, which trig ratio involves opposite and hypotenuse? That's right, it's sine, right? Remember SOHCAHTOA. SOHCAHTOA. Sine is opposite over hypotenuse. So what we're going to say, since we're using sine, is we're going to say sine of 20 degrees. That's the measure of angle N, right? So sine of 20 degrees, so the measure of angle N, equals opposite over hypotenuse. So x, which is the opposite, over the hypotenuse, which is 8.7 centimeters. And I'm just going to leave out the unit for right now. We'll say sine of 20 equals x over 8.7. And we are talking about degrees. Just for the sake of this, I'm going to get rid of the unit. So we'll see what we put in our calculator here. You don't put the degree sign in your calculator, right? So I'm just going to get rid of all units. No centimeters, no degrees. So here's what we're going to do. We want to isolate x here. Okay, we're going to isolate x. So how do we get x by itself? Well, we see 8.7 in the denominator, don't we? So if we multiply by 8.7, what's going to happen is those are going to cancel out, And whatever you do on one side, you have to do the other. So I'm going to multiply, get this out of the way, I'm going to multiply by 8.7 on the other side. So multiplying 8.7 over here, it's going to cancel out, and we're going to be left with x. So we have 8.7 times the sine of 20 equals x. All right, now I can actually get rid of these parentheses here. So it's 8.7. So we're saying 8.7 times the sine of 20 equals x. So let's put that in our calculators. Follow along with me here. So I'm going to say 8.7, and then sine 20. So I hit the sine button right there. All right, so 8.7 sine 20, and then I'm just going to hit enter. And that's going to give me a number. So that's going to give me 2.975. All right, so we're going to get x is about, so this little squiggly equal sign means about. All right, we're going to round that to the nearest hundred. Okay, so the number that I got was 2.97557. Well, where's the hundredths place? So we got tenths, hundredths, all right? So 7 is in the hundredths place. Now we need to look towards the thousandths place to decide if we need to round or not. If that 7 is going to stay a 7 or if it's going to go up to an 8. Well, since it's a 5, we're going to round up to 8, all right? So we have a 5 in thousandths place. We'll round that 7 up to an 8. So 2.98, x is about 2.98 centimeters. It's a squiggly equal sign because we rounded. Okay? So x is about 2.98 centimeters. So, I know that might have seemed maybe a little bit tricky for a second there. We're going to keep getting practice with this, okay? Maybe rewind it and see what I did one more time, if you feel a little stuck there. That gave us the length, though, of that side MP, that leg of that triangle, okay? So I'm going to go ahead and move on to number 2. So for number 2, I'm going to run through this a little bit quicker. We're going to find the length of YZ. So I'm going to say that's x. All right, we're asked to find the length of YZ. So now I'm going to look at what I'm given. I'm given the measure of angle Z, which is 38 degrees, and side XZ is 12.6 centimeters. All right, so we got to ask ourselves, in relation to angle Z, this 38 degree angle, right? What's the relationship between the side we're trying to find and the side that we're given in relation to 38 degrees? Well, ZY, X, right, or YZ, which is X, is the hypotenuse. That's definitely the hypotenuse of that triangle. Now, in relation to 38 degrees, that angle Z, XZ is the adjacent side. So, what are we going to use? Are we going to use sine, cosine, or tangent? Think so, katoa. Which one involves adjacent and hypotenuse? Well, that's right. It's cosine, isn't it? We're going to use cosine. So, for this one, we're going to use cosine, because cosine is A over H, adjacent over hypotenuse. All right, so here's what I'm going to say here. I'll work up here. How about this? I'm going to say the cosine of 38. So we use the angle next to the trig ratio, okay? Cosine of 38, so the angle, equals adjacent over hypotenuse. Well, what's the adjacent? It's 12.6 over x. Now, I can explain in class how this works in a little more detail, but I know you don't want to watch an extra like 3 minutes of this video. So I'm going to show you a quick trick. You might want to write this down. When the variable, which is x, right? When the variable's in the denominator, you can just swap. We can swap what's on the other side of the equal sign with what's in the denominator, okay? So I'm going to end up saying x equals 12.6 divided by cosine of 38. You see how the x and the cosine of 38 switch places? All right, so now I'm going to put this in my calculator. And we're probably going to end up having to round our answer. Okay? So follow me. Let me put this in my calculator. So let's see. Now, x equals 12.6. I'm going to put 12.6, and I'm going to say divided by cosine of 38. And you can close that parentheses, or you don't have to, but it might be a good habit to get into closing that parenthesis. And then just hit enter. Well, that gives us, let's see, 15.989. So about 15.989. So x is about 15.989. I'm going to go one more place. 6. Now, we're going to round to the hundredths place, right? What's in the hundredths place? 8 is in the hundredths place. 9 is in the tenths. 8 is in the hundredths. Now we're going to look to the thousandths place, which has a 9 in it. And that's going to tell us we're going to round up, right? So x is about, that 8 is going to round up to a 9. So 15.99 centimeters. That was our unit. All right? So 15.99 centimeters. Again, if that seemed tricky to you, rewatch what I just did. Highly encourage it. That way you'll be prepared for class tomorrow. I'm going to do one more example here. So let's check this out. We have a word problem here, actually. This says a contractor is building a wheelchair ramp for a doorway that is 1.2 feet above the ground to meet ADA guidelines. So that's the American with Disabilities Act, actually, who makes these. To meet those guidelines, the ramp will make an angle of 4.8 degrees with the ground. To the nearest hundredth, what is the horizontal distance covered by the ramp? And what is the length of the ramp? For the sake of this, we're just going to we're going to find the horizontal distance covered by the ramp, because I don't want this video to go too much longer. So let's figure out that. We won't worry about the last part here, although I'm sure you could find it. Now, we don't have a picture, do we? Remember, in geometry, if you're not given a picture, draw a picture, okay? So, there's a wheelchair ramp for a doorway that is 1.2 feet above the ground. So, here's the door. All right, there's the door, and it's 1.2 feet above the ground. Now, there's a ramp that leads up to it, and it makes an angle with the ground. So here's the ground right here. It makes an angle of 4.8 degrees with the ground. Okay, here's the ramp, here's the ground, makes that angle where it meets. Okay, and so we have a vertical component. This is going straight up, and then we have the ground, which is horizontal. Well, a directly vertical component that meets a completely horizontal component is going to form a right angle. Okay. Makes that L shape, right? So now, what we're trying to do is find the horizontal distance covered by the ramp. So I'm going to say the horizontal distance is right here. We're going to say that's x. So let's look at this angle. It's 4.8 degrees, right? In relation to that 4.8 degree angle, we're given 1.2 feet, and we're trying to find x. Well, 1.2 feet would be opposite of that 4.8 degree angle, right? And x is adjacent. So what is opposite over adjacent? Oh, that's right. TOA. Tangent is opposite over adjacent. So we're going to use tangent, aren't we? So let's set this up. We're going to say tangent 4.8 degrees equals, and again, I'm not including that degree sign. I don't need to. But that's going to equal opposite over adjacent. 1.2, and I don't need to include the feet here. So 1.2 over x. All right, so we see the variables in the denominator, don't we? Well, remember that trick I showed you. We can swap when it's in the denominator. Only when the variable's in the denominator. We can swap like this. We can say x equals 12. No, it's not 12. 1.2. I'm sorry. 1.2 divided by the tangent of 4.8. So now I'm going to put this in my calculator. I'm going to say 1.2 divided by, let's see, it says 1.2 divided by the tangent of 4.8. So tangent 4.8. Alright, and I'm going to close that parenthesis because I think that's a good habit. I don't think I did that in the first example, but it might be a good habit to get into. I'm going to hit enter. Alright, so that's going to give me 14.2904. Okay, so I'm going to say x is about 14.2904. We're rounding. We're going to round to the nearest hundredth, right? Nearest hundredth spot. So what's in the hundredth spot? It's 9, right? Well, in the thousandth spot is a 0. So that means the 9 is just going to stay the same. So we will say x is about, to the nearest hundredth, x is about 14.29. And what was our unit? Feet. Feet. So the length of that horizontal distance was 14.29 feet. All right. Here we go. Box that answer. Good stuff, y'all. Keep it up. So I hope that video was helpful for you. I get that some of this might be a little bit tricky. There's a little learning curve involved. But you just need to make sure that you are putting in your best effort to learn this. We're going to get some practice in class. Let me know if you have any questions. And come prepared, ready to work. Good work today. Thank you, Collegiate Scholars.